you multiply the bottoms.
Mhm.
So it's 12 times 1 over 2 times 3, which is 12 over 6. Now, you can also, we talked about this last year, you can also pre-reduce.
Mhm.
If you don't pre-reduce, you do have to reduce this. And if you don't pre-reduce enough, you still have to reduce this.
Mhm. So you would probably just go to. Oh, okay. So okay, that makes more sense.
It's up to you. Like, it doesn't matter to me, but you've got to either decide. You're either going to pre-reduce or you're going to reduce. Doesn't matter.
Okay, I guess I should reduce. So.
Be right back.
Mhm.
All right. Let me know if you have a final answer.
So would it be 3/1?
We're talking about 12 over 6. Is that right?
Yeah.
Okay. You can divide them both by 2. You always start with 2.
Mhm.
So that's 6 over 3.
Yeah.
Then,
And then you can go down to the 3 is the 1. Can't you go down so that it can the 6 is the 3?
you can divide by 3 top and bottom. 6
Yeah.
divided by 3 is
3
2.
over 2. Oh, it's true. That's right. Okay.
Okay, so maybe
Yeah, so
maybe
2
a
over
small
1.
thing there. I mean, just getting back in the swing of math. That's the little stuff that's going to work against you. So yes, that is correct. All right, now number 2 is correct, but do you know why it's correct?
Because I was just thinking that if you added the top, so that would be 10, which is 1 whole, and then 3 times 7, which is 21 over 10, or it'd be 21 over 100.
Well, like we just did, what did we do on the bottoms in the previous problem?
Multiplied.
So over 100.
So yeah, and
Okay,
then that would just
now
be.
I don't.
Would that be
No, I don't.
0.21?
Right. Yeah.
So yeah.
Now I don't see any of this on your paper. So that's kind of why I'm asking. Like, your answer is correct, but well, why is it correct? You know what I mean? Did you just guess? Did you, you just felt like it? Your teacher wants to see something like that.
Mhm.
Now, there is another answer, but there's another way to do it. But the way you've done it here is good. I like
Mhm.
that. Okay. All right. We should look at number 3.
Mhm. That one was just a guess. I'm not actually sure if that's correct.
Okay. So you had a problem kind of like this in the previous one. You have to make all of these into the same, and usually it's decimal is the best way to go. So
Mhm.
2/10 is what as a fraction?
Would it be 0.02, or what would it be?
2 over 10.
2
over
over
10. Okay.
Oh, it's
And
a
then how do
fraction.
you,
I thought it doesn't. Okay.
well, we do want to go to a decimal, but we have to start with a fraction. So how do you convert 2 over 10 to a decimal?
Wouldn't you? Wouldn't it be 0.02?
Okay, like what you're giving me is the answer. You're not giving me the steps, and that's where it's
Oh.
like, well, maybe you don't remember how to do it. That's fine, but no, that is not correct. The like if you won't get it to 100. Sorry, if you multiply top and bottom by 10, you get 20 over 100.
Mhm.
Then
Which
you can
is.
do what you're trying to do now, which is give me a decimal.
Mhm.
What would that be?
0.2.
0.2. Okay. And this is already 0.2. How do you go from a percent to a decimal.
That one I have no idea. I just can't.
We talked about this last time. You divide by 100.
Okay.
20 divided by 100, what does that become?
0.2.
Okay, so far, what do you notice about all the answers?
They all add up to 0.2.
They're all 0.2. So they probably all belong. What is
But
this
then-
last one as a fraction? And think of it as the shaded to the whole.
Wouldn't it be 2/10 or
Okay.
2/3?
Why is the whole 10?
Actually, no, wait, never mind. That actually wouldn't make sense. So if the whole is 5 and the shaded is 2, so 2/5.
Okay. So then to convert this to a decimal, you have to get to 100. How do you go from 5 to 100?
Multiply it by 20.
Okay, so you multiply the top by 20. What does that become?
2 times 40. And that
What
is
is that as a decimal?
0.4. So
Okay. So this mixed review is trying to get you to remember how to convert words to a fraction to a decimal, percent to a decimal, picture to a fraction to a decimal.
mhm.
All right, so 5 is correct. All right, let's look at number. We're going to go to 9 and 10 next.
Mhm.
We'll look at 9 first. So it says the nearest 10th.
Mhm.
10th. The 10th. This is the 10th place,
Mm.
not the
Okay.
tens place. The tens place is different. This is the
Okay.
tens. I'm sorry, that's the ones. Sorry, this is the tens place. Okay. So when you round to the tens place, you kind of like underline and circle, or circle and underline. I don't really remember how they do it, but you look at the number to the right of it. It's 2 round up or down.
You would round down.
Right. So those all round down.
Mhm.
These all round up.
Okay.
So that means that the 6 stays the same. Down means the same, I guess. So your answer here is 14.6. Yeah.
Okay. And the next one.
Why don't you try the next one here again?
Mhm. Would be 192.4.
Okay, so again, you identify the tens place and circle the
Mhm.
next one to the right of it.
Which is rounding.
Does the 7 round up or down?
It would round up, so it would be
So that changes this number here.
205. Or,
Yes.
yeah. So 0.5. Okay.
Okay, so definitely could use some more practice on rounding. But let's go through the rest of this.
And she also was talking about this, and she said this is never going to be on a test anymore, or maybe a little bit of it is going to be on a test, but not any. Like this is just to keep reminding us on what's
Well,
happening.
but it is important in real life. It's really
Mhm.
important to round to the if someone's rounding something, you want to know how they're getting there, because being off could mean a big
Mhm.
difference. Big difference. So, all right. So this is 4 by 3.
Mhm.
The area of a rectangle is base times height. It sits on its base. It has a height.
Mhm. So it would be 4 times 3, which 12. Okay.
Okay, and then units. So units here,
So 12 inches.
inches squared. Okay, so a length is like in inches. An area is inches squared. The volume, which you have not seen yet, is inches cubed.
Mhm.
All right, so why don't you find the area of the next one, please, number 7.
100 centimeters square.
Yes. And the units are just as important as everything else. All right.
Mhm. So
So
then,
for a triangle, like for number 8, we'll get 8
Isn't
up
it-
go ahead.
no, never mind.
It's very similar. It's base times height, but then you divide by 2.
Okay, so it would be 12.6 inches. Would that be squared as well?
Yeah. Now, which is the base and which is the height?
The base is the 4 inches. The height is the 3.
You got it. The area is 4 times 3 divided by 2, which is 6 inches squared.
Mm-hmm.
All right, so let me look at your other side here and see if there's any issues. So the only comment I'll make
I
is
didn't
that,
do
like,
18. That's all I know. 'Cause I
well,
was
yeah, the only comment I
easy.
make, it's not for me to decide if this is right or wrong. It's the identity property of addition,
Mhm.
because there is an identity property of multiplication.
Yeah, I know.
There's an associative property, or sorry, sometimes you have to add in whether it's addition, multiplication.
Yeah. She said we
Uh,
didn't really have to. She just said
okay,
she wanted the what it is, if it's identity or association or
okay.
like she just wanted to
And
know.
these look fine. These look absolutely
Mhm.
fine. So,
Just 18 is what I'm confused about.
right.
Would I just do like half? Because I'm not sure how to multiply.
Let me look at the other one. Yeah, you take half of each of those numbers in 18.
So 4x minus 10.
Yep.
Okay.
The rest look correct.
Mhm. Okay.
Okay. We should spend some time working on fractions unless you have other things you want us to work on.
Nope, I don't think so.
Okay. So let's look at some fractions here. 1/2 plus 1/3. And let's compare that to, we won't be able to do that. Let's do it differently. Let's go 1/2 plus 1/4 compared to 75%.
Mhm.
So this is a kind of a synthesis problem. You have to be able to add the fractions with unlike denominators. Then you have to probably make it a decimal, and then
Mhm.
make the percent a decimal as well.
Okay. So for the percent would be for the percentage it would be 75 over 100. So 70 over 100, and that would turn into 7.5. Would be as decimal.
Nope. Nope.
Huh?
You divide by 100.
Oh, you divide by
You're talking about the one on the right here?
yeah.
Yes, you divide by 100.
So 75 100 0.75.
Okay.
And then 1/4 plus 1/2. So for the addition, it would be adding the top and then adding the bottom.
Yeah, you add the tops, but keep the bottoms.
Okay, so it'd be 2. Okay.
After you make a common denominator.
Okay, so common denominator is 4. What did what is that? 3/4 is the is the percent. Then
It's the
when
fraction.
there's a fraction. But then when you turn that into 30 over 400,
You're trying to get to 100 on the bottom.
oh, you can do so. Um, mm, so, but 4 and go 20 times 25 times 4 is 100. So would you multiply the 3 by 25 as well?
Yes.
Okay. So then that would be
Okay, so what does this become?
was 3 times 25. Is it 61.5? That doesn't sound right.
Yeah, I'm not sure where you're getting all that. I mean, you're welcome to use a
Yeah.
calculator or you gotta do it longhand.
Okay. I'll try doing it longhand. So 75. Yeah, that makes sense. I'm not sure why I didn't get that immediately. That was weird. So if it's 75, they're equal.
They are equal. Good. Okay, let's look at another fraction problem. First thing I want you to do here is to convert this to an improper fraction.
Okay. So turn that into an improper fraction. Isn't it the 3 times 1 and the 10 times 1?
It's at 10 times 1 plus 3.
Oh, okay.
So
So
there's kind of a
13, 3. So wait, 13 tenths?
yes. All right. So the reason I had you do that is what if I want you to subtract something like this?
4/5, and then you could change to 13 tenths and then subtract. Okay. And minus, sorry, yeah, 4/5. Okay, so Would it be like? Can't. But would it be 26 or 25? I'm not sure.
Okay, well, you said all the right things. 13 over 10 minus 4 over fifths. You have to make a common denominator,
Which is
What's-
10.
which is 10. So how do you go from 5 to 10?
Multiply it by 2.
Okay. So then the 4
Times
also
8.
multiply by 2. Okay. So again, I'm not sure where you're getting that number, but
Mhm. So then you just keep the 10. And then
keep the
13 minus
10,
8 is
subtract the
5.
top. Yeah.
So 5/10.
Okay. Now does this reduce?
It would be divisible by 2.
5 is not divisible by 2.
Huh.
So you check divisibility with prime numbers 2, 3, 5,
Oh, so it could be
7.
5. It'd
Okay,
be
so
divisible by 5. So
divide
it'd
the
be
top.
1/5.
You're dividing both of them by 5. Like you said, the top is definitely 1.
And then 2. Sorry, 1/2.
Okay. All right. Let's try another one here. Let's say it's 1 and 3/8 minus 3/4.
Mhm. Then that would be 1 become 8. So it'd been 11 over 8, and then it'd be 4, 8, and then 5/8.
That does sound correct. It's 11 over 8 minus 3/4. 11 over 8 minus 6 over 8 is 5 over 8. Really good. Okay. So here's another problem we're looking at today. Let's say it's like 2/3 times 9/6. There's a couple of ways to do this. You can either pre-reduce or you can multiply the tops and multiply the bottoms.
Okay, so multiplying the tops would be 18, and 3 times 6. 18 over 18. So 1 whole.
Yes. All right, good. So let's do another one of these fraction things. Let's say it's 4/5 plus 3/4, and let's
Mhm.
compare it to let's go 1.5. That might not be fair. Let's just leave it. Let's just do this part first. Go ahead and add
Mhm.
those fractions for me, please.
Okay. Okay, so it would be 31 over 20, but that was improper. So should it turn into a mixed number?
So let me keep going here. Let's say I want you to subtract 1 and 1 and 1/4. Let's say now you want to subtract this.
Okay,
So
so 5/4.
how would you do that? What would you do to make a common denominator?
It would be 20 because 4 go to 25 times. And then that would be 5 times 25. So
Okay,
20 over
good.
25. But
You got the numbers. I mean, I don't know what you wrote, but you said it opposite. It's 25 over
yeah,
20.
sorry. Yeah, 25 over 20. Yeah, that's what I wrote. 31. So that'd be 6/20. And then you could reduce that, divide it by 2. And that would be 3/10. Divide that by. You divide that by 3. Wait, can you? No, so
Remember, both numbers
three
have to be
tenths.
divisible.
Yeah, 3/10.
Okay. Really good. Okay, let's look at this number again. We were looking at this earlier, 14.628. Let's round it to the hundredth place, the hundredth.
Okay, so
So that's
okay,
the
so it would.
tenths, that's the hundredths.
Okay, so
What would that round to?
it would round to 14.63.
Very good. And let's take the same number now and let's round it to the ones place.
Okay, so it would be 15.
You got it. Okay. And let's do the same thing for this other number. Let's go first to the hundredths.
So that would it would be 392.47.
Okay. That's good. And then let's go to the ones place this time.
Ones 392.
Good. Okay. Feel like you've got that down. Let's see here. So, all right, so let's do another one here. What is 4 divided by 5 as a percent?
Okay. .80.
So that's a decimal.
And then is a percent.
Yes.
Oh, okay. So
And you generally go to a fraction to a decimal
and to a percent.
to a percent, and you can also go backwards, but that's generally the progression.
So would that be decimal.
So maybe we haven't done this. You multiply by 100 to get go from a decimal to a percent.
No, so 80 times 100.
0.8
Oh,
0.80 times 100.
So that would be sure, like
So you're just moving the decimal over 2 decimal places.
okay, so 80.
Yes, yes.
Okay, so that's what I was going to say.
Okay, let's try one more here. Probably our last problem. What is 24 over 25 as a percent?
Percent. Okay, so 24, 25. That's harder. Trying to find the number that would go into both of those.
We are running out of time here, so let me go ahead and jump in here.
Yeah.
You multiply by 4, so this ends up being 96 out of 100. And then
Okay.
this becomes 0.96, and then you multiply by 100 to get 96.
Okay.
All right, so that's going to do it for us for today. So you can, lessons are just a tiny bit longer, but